Okay, in this section, lesson 10.5, the last section on conic sections, we're studying parabolas, which we've seen parabolas when we were dealing with quadratics, but now we get a little more of a look at what parabolas are and some more of their properties. A parabola is just a set of all points in a plane that are equal distance from both a fixed point called the focus and a fixed line called the directrix. A parabola has an axis of symmetry that is perpendicular to its directrix, and it passes through the vertex. So if this is my parabola right here, my vertex is going to be the lowest point on that parabola. In this case, it's the lowest point. It won't always be the lowest point. It could be the highest point, in which case your parabola would open the other way. But this would be your vertex. This dotted line down here is your directrix. And this directrix, they tell you, is perpendicular to the axis of symmetry. And your axis of symmetry contains both the focus and the vertex of your parabola. So we learned that parabolas have a vertical axis of symmetry. So, like I said, this could open up as shown, or it could open down. But parabolas also have horizontal axis of symmetry, which means they could open facing the left or facing the right. Almost like how a hyperbola did, except you only get one of the branches. The equations of parabolas use a parameter called p, and we're going to be sometimes they're going to ask us to find what p is. P is just a distance from the vertex to both the focus and the directrix. So if we look back at this picture here, they put this equation P1 D1 equals F1 P1F. So if you look, D1 is this point that's on your directrix, and P1 is this point on the parabola. So P1 D1 is a distance from the point P1 to the point on the directrix. P1F is the point on your parabola to the focus. And that would be that distance. So we could use that to find the equation of the parabola. Before we do it, let's go ahead and look at finding the equations of parabolas. So a parabola will have one of the following forms. You will want to copy this down. So a parabola will either be horizontal or vertical, much like ellipses and hyperbolas could be horizontal or vertical. Same is true for parabolas. They could be horizontal or vertical. The equation, direction, focus, directrix, and the graphs are given for you. Just make sure you copy these down. So you may want to pause the video to do that. So the important thing here is P, because the P comes up quite a bit. P is given to you here, 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 and here. So clearly P is an important part of your knowing any information about your parabola. So if you want to find P, one way to do it is to find the equation of your parabola and then set it equal to 4P, which is what we're going to do in our example shortly here. And this example is not on your notes, so you will need to copy it down and do it on a separate sheet of paper. So here's your example. Use the distance formula to find the equation of a parabola with focus f(0,3) and the directrix y equals -3. And then they ask you to find the value of p, which we will want to use our formulas to do that. So I know the focus is 0,3. I know the directrix is y equals -3. But how can I write y equals -3 as a point? So if you think of y equals -3 as a graph, as its graph, you would go down to -3 on the y, and any x value I picked, I should get -3. So any value of x would give me -3 for this equation. So what I could write is this. The directrix is the point x -3. What this says is that for any value I put for x, my y will always be -3. So you could say x is 1. Well, y would be -3, and that's true. So if this was 1, y would be down here. If I said -3, y would be -3. So that's why we write the directrix as the point x comma -3. And there's a point on the parabola. We don't know what the point is. We're just going to call it the point x comma y. We don't know what this point is. We're just going to call it xy. So what we're going to use is that notation that your notes gave you on page 12 there, where they showed you, go back up here for a second, P1 D1 equals P1F, where P was the point on your parabola, D was the directrix, and F was the focus. So I'm just going to write PD equals PF, just like your notes had it. Then I'm going to use the distance formula on the point and the directrix. So the point on my parabola was xy, and the directrix was x -3. So we're going to give some, in order to use the distance formula, we're going to give these points some names. So this is going to be the point x1, y1, your focus, and your directrix will be the point x2, y2. So inside your first square root, you're going to do x minus x2 squared plus y minus y2 squared. And that has to equal the square root of x minus x1 squared plus y minus y1 squared. It is okay to have these, it is okay to say if PF equals PD, it would be the same thing. You would just have these in opposite spots. So I can plug in my values for x, x2, and y2. So my point on my parabola is, my x point is just x. x2, I'm calling it x, so I have x minus x squared plus y minus y2 is -3. Your next one, x minus x1 is going to be x minus 0, because x1 here was 0. And then plus y minus y1 was 3. So when I can simplify this, x minus x is 0. And then y minus -3, that's just going to be y plus 3 squared. Just in case you couldn't see the squared, it was up there. And that equals the square root. X minus 0 is x. And we have our y minus 3 squared. Now we don't want to see the square roots in our equation, so we're going to square both sides to get rid of the square root. So 0 squared, that's just 0. Y plus 3 squared is what's left on the left side, and x squared plus y minus 3 squared is left on the right. So, and we want to solve this thing for y. So what we're going to do is we're going to need a either FOIL or box method y plus 3 squared, and then FOIL or box method y minus 3 squared. So I'm going to do that. On a separate sheet here. So first I have y plus 3 squared. That is just, and I'll use the box method since I know most of you will do that too. That's y plus 3 times y plus 3. Y times y gives you y squared. Y times 3 is just 3y. Y times 3 again here is 3y. And 3 times 3 is 9. Simplifying what's in here, this is y squared. 3y and 3y is 6y. And then plus 9. So that takes care of my first box method. My second box method I have to do is with y minus 3 squared. So here's my box. This time I have y minus 3 times y minus 3. Again, you'll play the same game. Y times y is y squared. Y times negative 3 is negative 3y. Y times negative 3 again is negative 3y. And negative 3 times negative 3 is 9. We can copy down within our boxes. We have y squared. Simplifying, negative 3y plus negative 3y is negative 6y plus 9. So I can rewrite my equation, which was originally y plus 3 squared equals x squared plus y minus 3 squared. I'm going to rewrite it using what we got when we squared y plus 3 and when we squared y minus 3. So y plus 3 squared we said was y squared plus 6y plus 9, and that equals x squared plus what we got here, y squared minus 6y plus 9. So to start solving for y, so we subtract 9 from both sides. Those 9s go away, and so are these 9s. So this is y squared plus 6y equals x squared plus y squared minus 6y. Going here, we're going to try to get all the y's on one side. So I'm going to subtract 6y, subtract 6y. So this would be y squared equals x squared plus y squared minus 12y. I would subtract y squared from both sides. So this would give me 0 equals x squared. These y's go away, just like these ones go away. Oops. So 0 equals x squared minus 12y. There's one of two ways you could go about finish solving this. Let's just go ahead and add 12y to both sides. So this gives me 12y equals x squared. Last thing you would do is divide both sides by y. So this would be, or sorry, not y, 12. So divide both sides by 12, sorry. So this would give you y equals x squared over 12. But if we're being consistent with the notation that your book is using for the equation of a parabola, we really want to say y equals 1/12 x squared. So this is the equation of the parabola. That's the equation of the parabola. The last thing we need to do is find the value of p. So to find the value of p, and I'm going to take this back to the page in your notes, which was page 13. To find the value of p, notice I have y equals 1/12 x squared. So this is clearly vertical. So y minus k equals 1 over 4p times x minus h squared. So I'm going to set my 12p equal to 4p. And that would, or sorry, I'm going to set my 12 equal to 4p, and I'll use that to solve for p. So I'm going to set 12 equal to 4p. Oops, can't see that. So 12 equals to 4p. Divide both sides by 4, and I get 3 is p. So now I have found the equation of this parabola, and now I have found p, which is what they asked me for. If you have questions, please bring them with you from the section.